Let's talk about lesson 19, the Pythagorean theorem. There are a couple of things about triangles that we need to make sure we understand before we can understand the Pythagorean theorem. One of those things is, what is a hypotenuse of a triangle? The hypotenuse of a triangle is going to be the longest side of a triangle. The other two sides of the triangle, or the shorter sides of a right triangle, for example, are called the legs. Okay, on a right triangle specifically, those form a 90-degree angle at their intersection. Okay, so if I were to draw a right triangle, this longest side is going to be the hypotenuse. This is a leg and this is a leg. The legs come together to form that 90-degree angle. Okay, so we have a property called the Pythagorean theorem. This says that the area of a square that is constructed on the hypotenuse of a right triangle is equal to the sum of the areas of squares constructed on the legs of the right triangle. Okay, this property of right triangles was known to the Egyptians as early as 2000 BC. But it's named for a Greek mathematician who lived around 550 BC. And the Greek's name was Pythagoras, and that's why this theory is called the Pythagorean theorem. The Greeks are so proud of Pythagoras that they've issued a postage stamp that actually illustrates the theorem. So I'm going to show you what that postage stamp looks like. Okay, we can see inside is a right triangle, and we have squares that are constructed on all the legs of the right triangle, and that's what this theory is all about. So the Pythagorean theorem says that the area of a square that is constructed on the hypotenuse of a right triangle, so that would mean taking this longer side, the hypotenuse, and actually creating a square from that side. Okay, so it says the area of this square is equal to the sum of the two shorter sides, the squares that are constructed on those legs. So if I drew a square here and drew a square here, just using the length of each of those sides, the Pythagorean theorem says I take the area of this square plus the area of this square, and it's going to equal the area of this square. So using that idea, the Pythagorean theorem, let's figure out what the length of side C would be. So here, if I have a square and each side of that square is 6 centimeters, that means the area of this square would be 36 centimeters squared. Here I have a square, 8 centimeters for each side. That means that the area of this square would be 64 centimeters squared. So it says to add these two together. So 36 centimeters squared plus 64 centimeters squared. So if I add 36 plus 64, I'm going to come up with 100, so 100 centimeters squared. That's the area of this square. So if the area of this square is 100 centimeters square, what would the length of the side be? Well, I know that if I take 10 times 10, I'm going to come up with my 100. So each side of this square would be 10 centimeters, and that is what the length of side C is, 10 centimeters. So we have a way that we can write this a little bit shorthand, if you will, a shortcut. I know you guys like some shortcuts. And the way that we can write this is we can say a squared plus b squared equals c squared. So A and B are the legs of the right triangle. Remember, those are the two that come together to create that right angle. C is going to be the hypotenuse. So if I go back to my original problem here, which was 6 centimeters, 8 centimeters, and C, let's just use the equation to come up with the answer. So a squared, it doesn't matter which side you choose first for a or b. So I'll just pick this one. So 6 is a, so 6 squared plus b, which would be 8 centimeters, so 8 squared, that's supposed to equal c squared. So let's do the math part. 6 squared is 36 plus 8 squared is 64. That's going to equal c squared. 36 plus 64, I know that that is 100. 100 equals c squared. So to solve for c, I take the square root of this. So the square root of 100 is going to equal c. Well, the square root of 100 is 10, and that equals c. That is what we came up with for our answer, 10 centimeters. So using the Pythagorean theorem, let's figure out what a equals in this figure. You can choose to draw these squares if you like, or you can just use the formula a squared plus b squared equals c squared. I'm going to go ahead and use the formula here. A squared plus b squared equals c squared. I'll choose this for a since it's already labeled as an a. So a squared, so in other words, multiply this by itself, I get a squared, plus, remember b is going to be the side that comes together with the other leg to make that right triangle. So b squared, or b, is going to be 12, so 12 squared equals the hypotenuse squared, so 13 squared. Let's do the math. A squared plus 12 squared is 144 equals 13 squared. 13 squared is 169. So I need to get the a squared all by itself, so subtract 144 from both sides. So 9 minus 4 is 5, 6 minus 4 is 2. That goes away. I get a squared equals 25. So to solve for a, I need to take the square root of 25. So a equals the square root of 25, which means a equals 5. This problem did not specify units, but we know this is length, so we would write 5 units. That is the length of side A. Okay, finally, let's take a look at this problem. I'm sorry, we have another one after this one. But let's take a look at this problem. We have a 3 by 4 and then a C. So we need to find the length of side C. So let's do a squared plus b squared equals c squared, the Pythagorean theorem. A and b are going to be the two legs that come together to make a right triangle. I'll choose the 4 for a. So 4 squared plus my b, 3 squared equals c squared. So 4 squared is 16 plus 3 squared is 9. 16 plus 9 is 25, so 25 equals c squared. To solve for c, let's take the square root. So the square root of 25 equals c, so that means that 5 is what c equals. Okay, so again, I don't know what the units are, so I would just write 5 units. And that would be my answer. All right, here's my last problem here. So what I have to do is I have to write an equation that illustrates the Pythagorean theorem. Okay, so I have sides A, B, and C. A and B are my legs, C is my hypotenuse. So I would take this side squared, which is simply going to be A squared. I'm going to take this side squared, which is a b, let's add it, so plus b squared, and that's going to equal the hypotenuse squared, which is c squared. That is my answer that illustrates, or the equation that illustrates the Pythagorean theorem in this particular problem. All right, that concludes lesson 99.